As we move into the next question, there is a standard normal distribution table that you can print out as well. So feel free to open that up and get this table uh, if you like to have a hard copy. So it's going to kind of look like this here. So this is going to be our standard normal curve. And if we know z-scores, this will also tell us the area under the curve. So notice that zero, notice that half of the area is the way these z-scores work, it's from the area from left to right. So the area of these z-scores, it's going to tell us the percentage of the area covered under the curve from left to right. So see if we can kind of pull up this first question here and see if we can kind of piece this all together. May use a calculator, not for sure. So it says find the percent of the total area under the normal distribution curve between the following z-scores. So let me pause for a second here. So it's a good idea to have this Z curve out here as well. Um, remember, I should have got the other one here, but remember here's zero. But if I do that, we have zero here, one's here, two's here, three's over here, then negative one, negative two, negative three. That would be what our Z score looks like here. So our question here is find the total area under the storm normal curve that's between the following z-scores, negative 1.5 and 0.65. So what they're wanting to know is how much area is there between negative 1.5 and 0.65. So if we start out with the z-score of 0.65, that's going to tell us the area from all the way over here to 0.65. So let's see if we can find that one first, the 0.65. So if I use my table, let's see if I can find my table here. Let me pause for a second. Your table's easier to find. So I'm looking for a z-score of 0.65. So there's zero point 0.6. If I go to 0.65, I'm getting like 0.7422. So I need to note 0.7422. So if I go to my document, so 0.7422, that would be the percent in form of a decimal. Now notice that that's the area from all the way over here to this here. What I need though is the other z-score, which is the negative 1.5. So z would equal this negative 1.5. So let me do a little bit better with my coloring. Uh, so get my purple back in there. Negative, so 0.65 would be about here. So notice that 0.65 was actually this area from 0.65 all the way over to here. So forgive me for my color not being all that great. Now, my other z-score is this negative 1.5. So if I go back to my table, if I find negative 1.5, negative numbers are the other way, negative 1.5, okay. So negative 1.50 would be this one here. No, zero is way over here on this one. So negative 1.50 is over here. So it looks like we're getting like in blue, so 0.0668. That would be the area of the curve at negative 1.5. So 0.0668. So 0.0668. What happens is that area though represents this part left of negative 1.5. So what happens is they only want the area in between here. So if I remove this section of the area, which is actually this 0.0668, that'll give me the area between these two values. So it looks like the math I need to do is this 0.7422 minus then this 0.0668. So if I do that math, 0.7422 minus 0.0668, that'll give me then this 0.6754. So 0.6754. But they want this to be in a percent. So I need to move my decimal two places to the right to make it a percent. So I'm now at 67.54%. But they want to round it to the nearest tenth. So do I keep it at 67.5 or do I round it up to 67.6? Well, that 4 would say round back down to 67.5. So 67.5% becomes my answer. So let's see what else we got here. So question 11, we'll do this on a different video. Looks like that's got a little more to it.